Hello everyone, welcome to solve this math Olympiad algebra problem, and here we have n to the power of 4 equals to 9, and we solve this problem for the values of n. So the very first step we are going to do is here first you focus on the exponent, and our exponent is 4. It means that we have 4 roots of this equation. So now we find these 4 roots. So the very first thing we are going to do is here first we move this 9 to the left hand side, and it will be written as n to the power of 4 minus 9 equals to 0. And after that we rearrange this equation and we write it as n to the power of 4, and it is equals to n square and its whole square minus we write this 9 as 3 square and this whole equals to 0. And after that here we need a nice square identity, and you know about this identity. If we have a square minus b square, it is equals to a plus b times of a minus b. And when you focus on this term, so here we have n square is over a and 3 is over b. And now we substitute these two values of a and b in the right hand side of this equation, so that our this equation will be written as so when we substitute this n square here, it will be written as n square plus 3 into n square minus 3 equals to 0. And now in the next step here we have two cases. So our first case is we write the first factor equals to 0. This is n square plus 3 equals to 0, and in the second case we put n square minus 3 equals to 0. So these are the two cases, and now we solve these two cases and we find the values of n. So here first we move this plus 3 to the right hand side, and it will be written as n square equals to minus 3. And in this case we move this minus 3 to the right hand side, and it will be written as n square equals to plus 3. So in the first case, in order to find the value of n, we need to take the square root on both of the sides. So here we take a square root, and this is square n square and its whole square root equals to minus 3 square root. So these 2 and square root are cancelled by each other, and we get here n equals to plus minus. Here we separate the square root on 3n minus 1, and we write it as square root of 3 into square root of minus 1. And after that we have plus minus square root of 3, and we know that the square root of minus 1 is iota. So we have n equals to plus minus square root of 3 into iota. So these are the two complex roots of the given equation. And now in order to find the other two roots, we need to solve this case. So here we again take the square root on both of the sides, and it will be written as square root of n square equals to square root of 3. So these 2 and square root are gone, and we get here n equals to plus minus square root of 3. So these are the two real roots of the given question. So here we have, these are two complex and two real. So this is total 4 roots of the given equation. And now we check these 4 roots. Is these 4 roots are satisfied our given question statement or not? Okay, so to check here, first we copy down the question statement. It is n to the power of 4 equals to 9. And here first we substitute our real roots. Here we substitute the positive real root, it is square root of 3, and here we substitute the negative real root, it is minus square root of 3. And now we substitute these roots and we check the behavior of our given equation. So this is our given equation, and now we substitute this value in the left hand side, and it will be written as square root of 3 and its whole power 4 equals to 9. So we convert this square root in exponential form, and it will be written as 3 to the power of 1 over 2 and its whole power 4 equals to 9. And you see here this 2 times of 2 becomes 4, and we will get here 3 square equals to 9. And this expression implies that 3 square is equals to 9 equals to 9. So this shows that the value of n equals to square root of 3 satisfied the given question statement. So this is the first root of the given equation. And now we check this root. So to check this root, we substitute this value in this equation, and it will be written as minus 3 square root and its whole power 4 equals to 9. And here you know that if we have a base is negative and its exponent is an even number, so it will becomes a positive number, because if you have minus 1 to the power of some even number, it is equals to plus 1. So we use this fact here. So this term equals to square root of 3 and its whole power 4 equals to 9. And after that, you see here the 3 square root of 3 to the power of 4 is equals to 9 by this process. So we directly say that this is equals to 9 equals to 9. So the second case is also satisfied our given question statement. And now we check our complex roots. So in order to check the complex roots, first we write these both complex roots, and here we have first root is n equals to plus square root of 3 iota, and the second root is n equals to minus square root of 3 iota. And our question statement is n to the power of 4 equals to 9. So now we check these two roots, and now in order to check these two roots, first we substitute this value in this equation and we check its behavior. So when we substitute it here, it will be written as square root of 3 iota and its whole power 4 equals to 9. And here we separate the exponent on both of these terms, and it will be written as square root of 3 and its whole power 4 into we have iota to the power of 4 equals to 9. So in the first case, we check that the value of square root of 3 and its whole power 4 is equals to 9. So this whole term is equals to 9. We simplify to the above case, and here you have iota to the power of 4, and we write it as iota square and its whole square. We break this exponent, and this is equals to 9. So after that we have this is 9, and we know that the value of iota square is minus 1 and its whole square equals to 9. So we know that minus 1 square is equals to plus 1. So you get here 9 equals to 9. So this shows that n equals to square root of 3 iota is satisfied our given question statement. So this is also root of given equation. And now we check the second case. So here we substitute this value in this equation, and we get here minus square root of 3 iota and its whole power 4 equals to 9. So when we separate this exponent here, so it will be written as minus 1 to the power of 4 into square root of 3 iota and its whole power 4, and this is equals to 9. So we know that minus 1 to the power 4 is plus 1, so we get here square root of 3 iota and its whole power 4 equals to 9. So this will becomes our this case. So in this case we know that this is equals to 9 equals to 9. So this shows that n equals to minus square root 3 iota is also satisfied this equation. So these are the 4 roots of the given equation, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.